Hello, welcome to today's webcast on API design, 3rd edition. If you haven't checked it out already, we highly encourage you to check out the API Craft group on Google. It's filled with folks who are doing wonderful things around API design, API implementation, and the business of APIs. This webcast and all the webcasts that we've done in the past and will do in the future are available on YouTube at youtube.com/apogee. And the slides will be available on SlideShare at slideshare.net/apogee. I'm Brian Malloy. You can find me on Twitter as Landlessness.
I'm Kevin Swiber. You can find me on Twitter at Kevin Swiber. Donald Norman talks a lot about design, and there's a particular article he uses to talk about the differences between simplicity and features. You know, we always get pounded with, hey, we need more features, while we need to keep it more simple. And he has a quote here that I really like that says, the issue isn't about simplicity, it's about design. So as we go through this today, we're going to try to give some pointers of how you can take what's normally pretty complex and add that usability to it for the end developer as well. So if you think about it, it's more like you're building a big cathedral, right, which has so much complexity. But to the people walking through there, to the users, it has to be beautiful. So that's our goal. On the agenda today, we're going to do a recap of previous editions of this API design presentation. We're going to talk a little bit about API modeling and how that can help you and your team. We'll get into some issues around security or some methods for implementing security in your API. Talk a little bit about message design. Get into some benefits of Hypermedia, and talk a little bit about modeling transactions.
So the design materials that we've covered in the past in the first 2 editions of this webcast are also available in an ebook called Web API Design. Like McDonald's has served billions of burgers, over 10,000 people have downloaded this design book, and it's our intention to base the next edition of the API design book on the webcast that we're doing today. As Kevin mentioned, in the past we focused on some aspects of API design, which we've recapped on this cheat sheet here. If you really look at the previous editions of this content, we really focused on URI design. That was the heart of the matter, and we hinted at some things around versioning, errors, and some client considerations. So what we really want to do today is go beyond these topics and talk about things like designing your messages, especially the response messages, and then take a look at some other things like what's happening with Hypermedia. Great. So how do we get started with our API?
So I talk a lot about API modeling, and a lot of folks have questions around that. So before we get too deep into what we can do with some of these responses and some of these different methodologies we can take on, I just wanted to spend a moment talking about what API modeling really is. And in the software world, we do modeling all the time. This is really using those same concepts except applying it to your API. So I usually advise folks to collaborate with all the stakeholders involved. That's marketing, business analysts, software engineers, key business people. These are folks in your API team most likely. Develop a language that everyone understands and use that language in building your resources, building out parts of your messages. It's really key to keeping everyone on the same page. And of course, document, and how you do that is up to you, right? A lot of folks use UML. Some people have their own version of modeling language that they use. That's fine. Whatever you're comfortable with, and then continue to iterate. The key point here is don't go off on your own, right? Because as soon as you say, you know what, I'm going to solve this for the company all by myself, you'll put in hours and hours of work, only to realize that, hey, marketing doesn't really use this term that way, or this really isn't the direction we want to go with our resources in our API. So definitely include that API team. They're a really important part. So security. I know through some of our Apogee webcasts we've talked about security before. We're going to touch on it again because it's a pretty important thing. The Twitter API uses, for their streaming API anyway, they have the option of using HTTP basic authentication, which is essentially a username and password base64 encoded. That's one way to go for sure. Amazon decided to roll their own authorization, their own authentication. So they built on top of HTTP authorization, and they have this AWS authorization type. Google is using OAuth. Specifically, they're using OAuth 2.0 and bearer tokens. our recommendation is to go the Google route, use OAuth 2. HTTP Basic is only so secure. Lots of folks are moving away from it. And rolling your own is a huge hassle. Typically we don't have the resources, the security resources to verify that our design is perfect and is rock solid. OAuth has been through the paces quite a bit, and there are even more secure options coming in the future for access tokens.
All right, so how do we approach message design? That's one of the key topics that we want to cover today. And we're going to do that starting off pretty simply here. First of all, regardless of how you design the message, you have to answer what kind of format you want it to be in. It's our strong suggestion that you support both JSON and XML. There are folks who have libraries that do great stuff with XML that they love, and there are folks who can't stand XML and have great libraries that do stuff with JSON that they love. Unless you have really strong business requirements or objectives that will limit you to XML or JSON, you ought to just support both. And if you're not sure about which one to make the default, pick JSON. If you know it should be XML, go ahead and make it XML. But if you're not sure, our suggestion is to make your default JSON. Now, what we're going to do here is talk about how you model in your response message both a single item, like a single resource, and also a collection of resources. And we're going to do that by taking a look at how three big public APIs do it. What you see here is a response from Twitter, Foursquare, and Instagram for each of the primary objects from those systems. So for example, in Twitter, you're looking at a tweet, in Foursquare, you're looking at a check-in, and in Instagram, you're looking at a media or an image. And what we do here is, what we're looking at is the top level view of each of these. So you can see Twitter is pretty verbose at the top level, Foursquare has included meta, notifications, and response, and Instagram has included meta and data. Now in the next slide, we're going to do a double click down on both Foursquare and Instagram to see what they reveal beneath that. So what we've done is a single click down on Instagram, so we're just seeing what's inside their meta attribute. And in the Foursquare, they had us click twice. Once we clicked on response, and then that said check-in, and then we opened up check-in. So what you see here is the real core object is represented at the heart of each of these. In the case of some objects, they're more verbose than others. The question is, is there anything for us to learn from this in terms of how we go about designing our primary resource? And this is what we think you got to do. Include a property for meta, where you can put in meta information about the object, and then include the actual name of the object type itself as the primary area where you hold the data. To contrast that, I'm just going to go back one slide quickly here. If you contrast that, Foursquare put their information under response and then under check-in. So I like the fact that they use check-in, but I don't like the fact that they bury it under response, because you've already separated the response from the rest of the metadata by having that meta tag there. And Instagram, they just call it data, which is kind of really annoying, I think, both to me and Kevin.
Yeah.
It's just kind of a throwaway word. So we like the idea of having the dog there, and I think it's really clever what Foursquare has done with notifications, because you can imagine every response that you get back from the API, there might be some global state or global information that's changed that you could also take advantage of, kind of piggybacking that information on the API response. So I think it's really clever that they've included notifications in the response, so that how that translates is for most app developers who are using this API, they go, oh, okay, the notification's coming back every time with every response. I can go ahead and include that and count on that information, so I can throw stuff at the top of the screen or somewhere interesting in my app. So that's our guidance on doing the resource. Kind of take the best of both worlds from Foursquare and Instagram and have a metadata area, name your primary resource, and then include notifications or other global information, if that makes sense. So that's a single resource. Now, how do we represent collections of resources? This is the case we have more than one. So we're going to take a look at this again. Now, what you'll see here is Twitter, Foursquare, and Instagram, they all do pretty much the same thing, which is throwing the object into an array of multiple objects. And with one minor exception, this is an important point, Twitter, Foursquare, and Instagram all include the same exact information in the collection that they do in the single. So that if you're thinking about how you would make this decision for your API, as Kevin and I were talking about it, I think both of our inclination was, well, what you really want to do is provide a limited subset of the data in the collection, and then when you want to drill down it, then you provide the bigger verbose thing with the idea that you're going to preserve on bandwidth. But at least me, I don't know if you warmed up to it, I really warmed up to the idea of including the same exact information in both the collection and in the single response. just because there's a sense of predictability there, and it seems more deterministic, and you can count on it being there. The one exception that I mentioned is actually Foursquare includes one extra property called source on the standalone resource. They don't include on the collection. I'm not really sure what the point of that one was. So when you compare all this stuff together, my feeling is do the same thing. Make sure you include that metadata, include your notifications or other global information that impact the app, and then put in a nice plural version of the primary resource. In this case, it would be dogs for our modeling. Include all that same information that would be included in a single resource, and you're off and running. Now, if you have a ridiculous model where the single resource is super huge and you are worried about bandwidth, then you can kind of trim down the one that goes in the collection. And although Kevin doesn't always agree with it, you can use partial selection to help you narrow that down as well. And you can see the previous versions of this talk for partial selections. So to do search results, this is an important point. This is actually a quote from the Facebook API documentation. Selecting results is not the same as searching. And sometimes it's easy to over-exaggerate why these are separate activities. But essentially the idea of searching is you can create just some sort of natural language string in a query box, and it can search across resource types. So instead of limiting to say select like, hey, give me all the photos, you're saying generally give me anything about foobar, and you get the results across all the resource types. So here let's take a look at how 3 APIs approach this. This is Bing, their search API, Google Custom Search, and Reddit for searching their listings. And without taking a lot of time to drill into the details of what is coming back in the response design here, just keep in mind that there is metadata about the results, there's metadata about the query, and then there's the actual data itself that is being returned from the search. So it can get pretty overwhelming if you really start digging into this to figure out which stuff should you include in the search response and which stuff you should not. So here's our suggestion. For the most part, follow Google Custom Search. They do really good stuff on this. What we did though is we took the key pieces of metadata that they included. They put it under a couple of nested objects. We just consolidated all under one metadata property. So here we're saying include the limit and offset for the pagination, include the total results that are available, right? Because that's how you want to do pagination in a compelling way. And importantly, include the query string that was sent to make the query happen. And then if you want to show off how fast your search engine is, you can go ahead and include the search time. And then of course, in the results property would be the actual array of all the results that came back from the search. So that's that. On to the next one. Now we're switching gears here. How do we represent links inside the response?
Sure. So links. Links are cues inside of your message that point to a different resource, right? So if we look at the Netflix API, they're using something called web linking. There's actually a spec around this, an RFC. You can see an href there that's pointing to a URL where you can find what we're looking for. You see a rel value there in that link. And then there's special meaning to that rel value. If you look at Netflix's documentation, they'll say that person.actor is an actor in a film, and a title associated with that, Elijah Wood. If you look at the GitHub API, they were going for more of a Netflix API when they were in beta, but now they've changed it up a little bit. And under their organization is a URL. So if you look at a repository that belongs to an organization, you find the organization, it has a URL, you would go to that URL to get to that particular resource. Our recommendation is to follow Netflix and the web linking spec. And a big part of that is because there is a specification around that, and you can point your developers to that to understand how to interact with your API, which is hugely important.
Before we go off links, and you might have said it and went by pretty quickly, how do you help people understand if they should put links in their response or not? Is it just you always do it, you never do it, certain times you do it? What's the heuristics for when you use links?
Yeah, so I mean, links are really helpful for developers, right? So if you're looking at a response message and you see that there's a relationship there between, say, a film and an actor, you can look at that message and then continue on your exploration of that API, right? I find myself going back to the documentation less and less and just able to focus on exploring that API. So that's one huge benefit. Yeah,
that's great. And I think to contrast this, the alternative is you hear the word templating thrown around a lot. Like instead of giving back the link, you might just give back the ID, and the developer has to know that this ID gets plugged into the template in the right spot. So in this case, coming back, here's a catalog of people. So if I just saw the people ID, then I would grab that ID and say, hey, I'm going to do a get on /people and drop the ID in at the end. That's sort of the trade-off.
Right, correct. And that takes some context switching if you're doing exploratory work, and takes some different coding structures in there to make sure that you're doing the URI templates properly.
Right. And the other kind of thing that's correlated to this is the whole idea of going out of band. If you don't include the link in the response, then the developer's going to have to go out of band, meaning go read some documentation or something outside of the API to figure out what to do next. So
right, and we all know that context switching has a big cost.
It does. Right on. Cool beans.
Okay, so we'll move into how to represent actions. And as we were doing this, Brian kept saying, like, is there a better definition for this? Like, well, what are actions, right? And actions are typically state transitions coming off of that particular resource that you're looking at. So we can get to some of the examples here. GitHub documents this. So again, we see we're going away from the message and we're looking at documentation to figure out how to do this. In this case, we're doing an update to a repository on GitHub. And they document, the HTTP method that you need to use, the URI template you need to use, and all the input fields. I couldn't find a good example of this out in the wild in public APIs, but if you look at the form-based API example, it is taking exactly what GitHub is doing and applying that in line. Form-based meaning like HTML forms. So if you're familiar with HTML, you have a form tag, there's a method, there's a URL in there where you can, where you go to execute that method, and there are a list of fields. Right? So we're recommending the form-based approach. Seeing this more and more in the wild, not too many folks, but I think it's something we need to keep an eye on. Moving towards that form-based approach allows a lot of things. For instance, hidden fields are a big thing that we use in HTML forms today. We throw those into your API. Right, that means you have data coming back and forth, keeping that stateless nature to your API, and still getting what you need on the server without affecting your clients at all.
So to make this come to life for me, when the action comes back in my HTTP response, my code is going to go ahead and parse this, and then whether I'm creating an HTML form or an iOS form, an Android form, I'm going to introspect all the properties here and build my form based off of that.
Exactly.
And then at the end, the method that is telling me, patch in this case, is going to go back to this href. So if I were building an HTML form, that's obvious, it's going to go there. And if I'm doing iOS, it's going to be an API call with that data.
Correct.
Cool. Got it. How do we represent metadata?
So we have a couple examples here. Flickr includes some metadata in line with their items. In this case, it's a photo. There's not a whole lot of metadata there, but some exist. Dropbox, they decided to have an entire metadata resource to access. So, if you go look at a file itself or a folder in Dropbox, there's a lot of data associated with that. If it's the path, if it's how many bytes are there, all sorts of things. So, we like having metadata in the response itself, and we usually favor that. But there are cases to consider, having that meta resource. And again, it's when your metadata becomes so significant that it actually should be modeled out in your API. So I think this makes a lot of sense for Dropbox, and it makes a lot of sense for Flickr. Maybe they should have tucked it all under some kind of meta heading. Interesting. But it's good to have that in mind for that.
So we're talking, everything we've been talking about for the past few minutes is around designing the response message, the message design. A lot of what hypermedia thinking does is address the message design.
Right.
So what can we learn from other hypermedia types?
So Atom and Atom Pub is one of the first media types out there to be used for APIs. Its intention was for feeds and editing, articles in a list and things like that. But one important thing that they showed us is to build a protocol around link relations. If you see that link rel equals edit, it should be in bold there. Yep. They're using that standard link relation type to communicate to the developer or the client that's consuming this API where to go to edit this particular resource. We don't see this too much, but
XHTML, that's not for
XHTML,
APIs.
right?
That's for UIs.
That's not.
What's
for
going
APIs.
on here?
So the cool thing about XHTML is that it's valid XML, which means that parsers like it quite a bit. It's kind of difficult to build an HTML parser because they kind of allow quite a bit going on in there, whereas XML is pretty well formed. So this is from a site called rStatus. They're implementing an ALP specification that you can find out there on the internet, and ALPS has certain meaning around classes such as avatars, users, userless search. You can see that in XHTML we're including that in there, and you really get that semantic connection. So some people might say it's a weird use of XHTML, but it exists. It's out there.
And there's a gentleman on API Craft who's really been pretty active about pushing XHTML as a standard.
Right.
It's interesting stuff. Cool.
Okay. Now we have a few JSON-based hypermedia types. This one's HAL. HAL is really suited towards augmenting your existing API. So if you have a JSON message out there, adding this underscore links to your existing JSON message, which will hopefully not collide with an existing underscore links property you have in your JSON object, can start adding some of those hypermedia elements. Here we see the link relation becomes like a key in this key value pair inside the links object. So we have a link to self, next, and previous, iterating through orders in a collection. So sometimes there are options for augmenting your existing API without breaking clients.
Cool.
Collection plus JSON is a media type out there that is trying to model Atom Pub and what they were doing, except in JSON. So it's a little more palatable to some folks. It also allows for extensions, and in it you can see that there are queries that are modeled here, but there's also write templates that you can use. So it's getting back to those actions and allowing actually editing the different resources that you have. So, and then there's Siren, and Siren has a mixture of all of these. So it's really taking the goal anyway is to take a lot of the best of what we know about hypermedia and make a media type that is suitable to APIs. So in here we see actions, just as we saw when we were talking about using form-based APIs, and entities, which imply relationship there. They are also using that link relation that we talked about being in the web linking spec, and also links for navigational purposes, so next, previous, things like that.
Cool. And who's the author of Siren?
I guess I should disclaim that I am I am the author of Siren.
Cool. Siren's cool. So, all right, how do we accept binary data?
All right, this question comes up a lot on the API Craft group.
Because there's no one way to do it.
Because there's no one way to do it, right? And it seems that folks only need to do this sometimes, but when they need to do it, it's very important that they get it done soon. So one method is to use Multipart form data. This is exactly what your browser does when you're filling out a form and you need to submit a file. This is kind of what that looks like. There's some content disposition that you put in there to name the field with a value, and you have the option of assigning different content types to each bit that you send. So the second part there is a JPEG image that's being sent along with that. So you can do the same thing in your API.
Cool.
Another option is to just inline some base64 encoded version of it. So the downside to that is when you base64 encode it, it gets a little bit bigger, but at least you can put it in a textual representation, right? So you can have your client do that base64 encoding and then just dump this string in there and submit it up to the server that will decode it. And then the last option is a two-step process. It's creating a new resource to hold that metadata that you have, and then submitting a file that attaches to it. Right. Cool. And I always say, opt for multi-part form data first. There are a lot of tools out there that will help you do this as a client, and that's pretty significant. A big thing, though, is no matter which one you choose, and I think multi-part form data is the way to go, just be consistent. Don't have 3 or 4 different ways in your API to upload a file. It's just not worth the headache. Caching. Caching is another one of those topics that comes up.
And really, we're not talking about everything to do with caching. It's what are the design implications around caching. Is that right?
Right.
Cool.
So, first of all, we'll go through different ways to do that, right? So, there are 3 main ways to do caching. One is expiration. So you use a cache control header to say, this is private, which means that only the client can cache this. No proxy in the middle should be caching this. And a max age in seconds. So this is 30 days, I think. This is a direct message to the client saying, hold on to this, and it should be good for this length of time. Right? Another method is e-tags. E-tags are sometimes calculated as a checksum of a file or different data elements that you have. You can use your some databases do a good revision number on each document that they have, or you can manage your own keys for e-tags, much like Twitter does. They have their own key generator service. But yeah, so when you pull down a resource representation, it'll have an e-tag associated with it. And if you want to make sure that you have the latest, you can do a get at that same URL and include the header if none match, and include that e-tag that you received. And if there are no e-tags with that, then you get the latest response. Third option is using the last modified header as a hint on how fresh the representation is. If you get last modified back with your representation, the next time you go to get it, you can put a header in there that says if modified since with that same date, and you will only get it back if it's newer. So it's a network call, but you don't get the full body of the message back. While there's no one particular caching method to do at all times, it really depends on use cases. A common pitfall that we get into is that we don't think about the client. We think about caching in terms of saving resources and saving bandwidth on the server, but we don't think about it on the client, right? A lot of times that client doesn't need to make another network call, and that saving that time is very valuable for them. So just keep that in mind.
Do we need a JavaScript API? So often folks ask, we see this in a number of ways where the API and maybe the domain of the system itself has a lot of complexity around it. So maybe you do an API for, say, payment processing, and you can accept payments from credit cards, checking accounts, PayPal, Google Wallet, and so on. Your API, in order for a developer to learn how to use that API and then express how to use it through the user interface to the end user, it can be very difficult. So oftentimes there's pressure on the API to maybe want to start giving hints about UI elements or how to actually use this. And that's always a mistake. You want a clean separation between the API and the consumer. However, some people think of this as an SDK, some people call it an API. The question is, there's so much understanding of JavaScript, at least at a rudimentary level, that this kind of presents itself as an anomalous thing. Hey, we built a nice API, we have a little bit of resources, should we use those guys to build the next version of the API, or should we do a JavaScript API? I'm feeling more and more that if you're doing an API and you want really good adoption, and you want to have an easier job of explaining how to use it to folks, you should go ahead and also create a JavaScript library or a JavaScript SDK or API, however you want to call it. And if you want to see an example of folks who are doing this really, really well, take a look at LinkedIn. The JavaScript API does a great job of handling all of the authentication stuff, so the developers don't have to get down in the weeds on that. And the way that the JavaScript library maps onto the core API is really transparent, and it fits really nicely. So I do recommend, if this is a question you were thinking about, go ahead and tackle the JavaScript API. Now, should you do the iOS API and the Android API or SDK? Yeah, maybe, but take a look at your priorities. But definitely, if you had to do one, I would do JavaScript and take a look at LinkedIn. Cool. What about posting data?
So we talked a little bit about actions and submitting changes to state of our representations. This is more about, let's talk about how do we serialize that data? How, in what form does it take when we take that request and send it to the server? One option is to use application xww form URL encoded. Really long name, but it's really simple. It looks just like a query string. So some folks send XML as the request body. Can get kind of verbose sometimes, as XML tends to do, but that's an option. And then there's JSON, right? So we favor the form URL encoded version. It's pretty simple, it's easy. There are certainly many different tools out there that folks can use for that. Is it wrong to use the alternatives? No, but definitely favor the simplicity.
Cool. All right, now how do we handle transactions? Now, the caveat here is we're not going to do a deep dive on transactions. We're just going to hint at it, and very likely we'll do another webcast just on how to handle transactions with an API. But let's take a look at it at least briefly.
Here's just some hints in one way you could do this. You could model the transaction directly in your API. right? And for this example, we're going to use the concept of a shopping cart. You can have, in our API, we have some user, they create a shopping cart with a post, they get a 201 created back. Then, from the product catalog, they add, some mittens to their cart, and then they check out, right? I mean, it's just a matter of creating that transaction, adding items to it, and then doing a commit, right? Certainly problems can happen. You can get errors back, and you'll have to deal with that. But again, we'll talk more on that.
Cool. So in summary, we talked about the previous editions for URI design. We've got an ebook out there, and there's a cheat sheet at the top of this slide deck that can just run you through really quickly what our suggestions are for designing URIs and a little bit on errors and revisions. As Kevin said, start with API modeling. It's a good idea to create a common language and a common understanding among your API team. Use OAuth, the latest version of it, for security. It's almost always the right one to use. And keep in mind when you're designing your response messages that the message design is for developers to parse into those resources into some objects in their language. And it's a good idea to be terse and brief and let them get to the data as soon as possible, while also including metadata, notifications, and things like that. We give you a quick overview of what's happening in the hypermedia area with the different specs that are out there. And as you dig into those, you'll see there's a lot to learn in terms of how you should think about links and designing your messages. And finally, we touched briefly on transactions, and we'll do more about that later. At this point, we'd like to go over to questions, and I know there are some piling up in the Q&A area here, but feel free to start adding some more. The first, this is from Burke Autry. Thanks, Burke, for writing the question. The question is, they may get to this, but we have an exception, in quotes, which is very verb-like. We have a payment engine that we want to expose, and we can't decide on the best way to model it. We don't need to store the results, no post or put, and Git seems strange. Any thoughts? So, we encounter this pretty often. If you are doing things in your API, and the words that express that are things like calculate or exchange or convert, oftentimes those are non-resource like API elements, and we suggest, and you can read this in the ebook, we suggest to be very careful to use verbs for those types of things and document and kind of demarcate that for the most part this API has a bunch of resources in it, but there are occasionally things you need to do which are much more like algorithms, and no data artifacts get created from it, so treat them separately. And yeah, I like the idea of using verbs to do that just as you outline.
And that's a good general rule for design, right? Like nothing is ever perfect. When you make an exception to the rule, make sure it's documented.
Right. Cool. Michael Stewart asks, how do links work with the JSON response? This was probably asked at the point where we'd only shown XML. Should we go back and show, is that in Siren? Got an example of that?
Yeah. Right. So
right there.
There's a link at the bottom there that is just a link to self, which is really common. Also, the entities can be seen like links here too, where we're on an owner resource and we're linking to a dog. So Siren includes all this in an array. All the rel values are in an array because we have more than one. Some other formats don't do that, but an example here is HAL. HAL does more of a key value approach where you can only have one rel value for the resource. So.
Cool. Thanks again, Michael, for asking that question. The next one is from Jason Hunt. Maybe I missed this. Why would you put this form-based API on top of REST? Doesn't REST already have a URL and action?
Yeah, so that form-based API is just communicating which action you should use to do that and which URI you should use to make that call. And again, the alternative is putting all that in documentation. But you lose a little bit of evolvability on that, right? If your URI start changing, if maybe you want to switch from a patch to a put for certain architectural reasons, you'd have to update your documentation, potentially break your clients. Putting it right into the message itself allows for that evolution.
Fantastic. And really, just to stress this is, when you're talking about doing one of the actions, it's about not the current request and response, it's about what are you going to do for the next request and response.
Exactly.
It's about moving it forward. Cool. All right, the next question is from Lon Miller. Lon asks, so for the meta slide, should each URL offer a meta service, foo/service/meta, foo/thing/meta, and so on? So we hinted at it. How would you do, that you should think about having a dedicated meta resource, so how would you actually do it?
So I don't think I'd have a meta service. That doesn't feel right to me. I'd make a meta resource, but only for those resources that require it. Again, we really favor putting that in the message, encapsulated in some kind of meta object inside the message when at all possible.
All right, next question from Andreas Tosh. He asks, XML versus JSON. Isn't JSON limited / less maintainable? For example, you want to add attributes later, or for example, if you want to add the currency to a price later on, see slides 102 to 112 of something on Google, which we won't click on now because we can't share the screen.
Sure. This is almost like the which is your favorite text editor battle. There are pros and cons all over the place. With JSON and with some of these hypermedia formats I've shown, they are extensible. If you look at the spec, you can add, I think there's a new link relation type called profile. I don't know if it is a full-blown standard yet. It might be an internet draft, but the profile link relation would be a way to mix in certain functionality into an existing JSON API.
Right on.
It would work with XML as well.
Cool. My take on that is XML definitely has a much stronger set of tooling and wisdom and knowledge that's out there in the world, especially in the Fortune 500, Global 2000 enterprises. JSON is the representation for JavaScript, and JavaScript is like everybody's second language in the world of programming, if not their first language. So those are, I think, we suggest supporting both. Make JSON your default, but definitely there are cases where XML is going to make more sense. Lon Miller asks about e-tags. Is the e-tag value a CRC or a transaction receipt number, or both? Is e-tag only useful for a deterministic service?
The e-tag can be calculated any way you want. I mean, there's no general rule in HTTP spec about how you calculate an e-tag. So again, use whatever makes sense.
Cool. Jason Kemp asks, how are patch requests handled on the back end? Are you parsing it into a dynamic SQL string, or what are the best practices around that? We're currently using an ORM entity framework. Any thoughts on that?
Well, there are a bunch of pieces to this question here. First of all, if you're putting your API directly over your data layer, there's a lot you have to think about there. Would you generate a dynamic SQL string? I don't know. That doesn't feel too comfortable for me. I'd probably model in some kind of API model between that service and the backend data stuff.
Good, cool. Mike Rovsky asks, what is your opinion of OData? Kevin, what's your opinion of OData?
What is my opinion of OData? I think the OData guys are headed in a good direction with where they're going with the latest version. At least last I heard. I'm not entirely close to it. I think they were based on Atom Pub at some point. Maybe they have other formats that they're doing now. Again, this is kind of how do we model SQL over our API, right? They really get into how you filter results.
And you're never comfortable with that.
You know what? There are cases that I am comfortable with that.
Okay.
Usually, I'm not.
Okay.
So,
cool. Question from Vivek Dubey. In case we would like to call APIs from static pages, for example HTML, and not from PHP or other programs, I imagine the key thing is that those other programs run on the server. Is there any way to embed the credentials, irrespective of OAuth, basic, etc., and to not make them fall prey to other eyes? We deal with this all the time as we're building apps.
Yeah, so just with static pages, how do you protect that?
You don't.
You don't, yeah.
And that's where, using, we of course, Apogee, we have a free product available on apogee.com that will allow you to create a proxy, and you can store some of that information in the proxy, keep it off of the dynamic pages, and do some stuff back that way. But it's pretty tough overall.
Yeah.
Okay, next question is from Vish. How can a client request templates for creating new resources? And I think that's what you were talking about with the action.
Right, actions do that. In Siren and in Collection plus JSON, they have write templates.
Easy enough.
Yeah. So the answer is use a media type that supports
it. Cool. All right. Anis Flexwala asks how to facilitate the XML transformation of JSON response. There are a bunch of tools that can help you do that. There's open source packages. Apogee has some stuff. Other folks have some stuff to transform XML into JSON. Sometimes it's really straightforward. In fact, the XML to JSON is actually often simpler than the other way around. But there's good tools out there. They're easier to find on Google. You can start with Apigee if you want. Okay, Christopher asks, to provide minimal security/tracking, is an access token enough? I have a bunch of JavaScript widgets which clients will embed into their user interfaces, and I'm planning on providing each client with a token. The data is not private, and OAuth seems like an overkill.
OAuth might be an overkill if you're not using user data, right? If your service manages user data and you have clients that need to access that user data, OAuth is perfect. Otherwise, one of the other methods might better suit your needs, and that's fine. They could be SSL certificates, even client SSL certificates, and basic auth, depends on your need.
Right on. David Campbell asks, or I guess is trying to influence, can we find a better word for notifications and response? I think we absolutely could. That has way too many syllables in it. But that's the one that we like and seem to have the most relevance for what was going on. The real point for putting notifications in there as our suggestion was just to say you can have a section for metadata about the response. You should have the response itself, but then keep in mind that there are things that are happening around the app more broadly or more globally that could be interesting to store as a separate thing too. So for your app, it might be notifications. For someone else's app, it might be alerts or info or warnings, whatever it is. That it's just sort of like the idea of the pattern that we liked was the idea of piggybacking more generic stuff on top of each response, because the app could just render it when it gets new data back. Great point though. Thanks for that question. All right, next one, Matthew Reinbold. What are some rules of thumb on authorization versus authentication? Meaning making sure the client has permission to make requests versus a user having permissions to modify their data. OAuth 2 for both?
Yes, OAuth 2 for both. So in OAuth 2, whether or not the client has permission is something that you're going to have to manage in your client registration process and your client policies. And let's see, the second part was about versus a user. Okay. Authorization, authentication. Did we get it? Was that it?
Yeah, I think so.
All right.
And how many times have you read the OAuth spec in the past month?
I think I'm up to 7 now.
Fun document. All right, our last question for today from Peter. How many items would you limit a JSON response to in the case that each object has 10,000 that each object has 10 key value pairs, i.e. something like sending 300 merchants location to the client in one response too big / network heavy. In the previous version of this, we talk about just a rule of thumb around 10. We have 10 fingers. We have a mostly decimal based counting system all over the world. So I think using 10 as your default makes sense. If your data is really, really big, make it smaller than 10. If it's really, really small, make it bigger than 10. But I think starting with 10 is a good rule of thumb. And
test this out too, right? I mean, have clients out there that you're testing with. And if you know you're going to have a bunch of mobile clients, see how this feels on a mobile client. If you know you're going to have a bunch of back-end systems that are clients, test it from there, because that could change your payload.
Folks, thanks a bunch for tuning in today. We appreciate your questions and your engagement. As we mentioned before, this webcast and all our webcasts are available on YouTube at youtube.com/Apigee. Please join us on the Google group called API Craft. If you just do a search for API Craft, you'll find us. Fantastic community, folks, all moving the craft of APIs forward. And feel free to contact us directly. Those are our emails and our Twitter accounts. And of course, there's the Apigee Twitter account as well. Thanks for tuning in, and we'll catch you next time.
Thanks, everybody.
Bye now.